All right, so this is almost the end of the first project that we have, the strobe light project. But the only two things that we need to do left is use the jump function in order to use subroutines in order to make our code look more understandable and less like spaghetti code. And using the CP function in order to stop the left shift when reaching the most significant bit, as well as the CP function to stop when it reaches the least significant bit all the way on the right side. We're gonna focus on the jump function today, and then I'm gonna do a little bit of research and figure out more about the CP function, and then I'll make a video about that. But essentially, what we are going to do is boot up THRSim. For simplicity's sake, I already have the code written out, but I can explain how to write it yourself. You can pause it and write it yourself if you want, but hopefully you can understand the logic to not really need that. But essentially, what you want to pay attention to is this. This is like the master code. Um, all this down here, this is just the actual individual steps that we are jumping to when we need to call upon them. But you guys recognize what this is. This is just the initialization and starting the count, loading a value to accumulator A, and storing it as LED1. What's interesting is this JMP function, jump, and it's going to be pointed at delay 1. So when it's on the right side, that's telling your jump function where to go. And when it's on the left side, it is, so to say, it's going, okay, titles are very vital in the jump function. When you have the title, it's telling your function where the possible places to go are. On the right side, it's more like you're sending it to the address, and on the left side, it's the address itself. So as you can see here, we have JMP delay 1, and delay 1 is down here. So it would be skipping these two pieces of code, or these 4 lines of code right here. Um, as you guys can see, I didn't do much to the actual code itself except just move it out the way. This is still the standard delay function. As you can see, we use standard loops and decrementing it, the value stored in accumulator A by 1 until we reach 0. But once that's done, then we go back to the jump function, going to continue 1, being back up here at the top. As you can see, it will load accumulator B with a value of 7, and then it will go down to another jump function, which I called shift left. Shift left is located down here, so it'll be skipping essentially all this code down to this part right here. And it would just be the same iteration as you see before. It's just going to be taking the value of accumulator B and shifting it to the left and decrementing it by 1, also adding the delay that's also built into the code. Um, if you want more explanation, you can see the previous video when I talk about integrated loops. But this is just focusing on the jump function. The jump function now will be called to continue 2. Continue 2 is located back all the way at the top, so all this will be skipped, and it'll go up to here where you're loading the value 7 to accumulator B as well, or again, and then jumping to the shift right function. The shift right function is at the bottom. So it will just do the same thing as before and shift all the logic back to the right one at a time until it's at the least significant bit. And from there, we do not need to have any more jump functions because since it's already located at the end, you don't need to actually properly end the code in the master code. It'll just end here because it's at the bottom. Essentially, that's what it will do. So let's just change something just so that we can make sure that it doesn't crash. Let's also reset the simulated chip, continue, and once you see, it should have the same functionality as the code you have before, but it will just look a little bit cleaner because this is the only thing that we're really concerned about. This is just each individual task that needs to be performed. So let's press the play button, and as you guys can see, it has that functionality. So that's pretty much it for this video. It's going to be a really quick one. But the more we understand, the less we need in-depth explanations, and the more I can save you guys some time. So yeah, that's about it. If you have any questions that you need answered, oh, one thing that I will mention, this is still a lot of code to write. That's because we have to actually use. It's just kind of making this look cleaner, but it's not actually reducing the lines of code that you need. One thing that I've realized is that if we could have like some conditional statements, like if then jump, then that would be able to actually decrease our workload by a whole lot. But I don't really see anywhere in the first couple of lessons that discuss the matter. So maybe in class on next Tuesday, then we can actually talk about conditional jump statements to actually make our code a little bit more optimized. But that's neither here nor there. Even in my own time, I'm going to do a little bit of research to see if there's a way to do that. But it's always a little bit hard when you're talking about different individual microcontrollers. But that was about it. That was just a little author's note. But thank you, everybody. I hope to see you soon.